In this video, let's see the topic on proportioning of footing. First of all, myself B. Chelapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So first one is proportioning of footing. So normally the structure is supported with number of columns. So these columns carrying a different load depending upon their location, their sizes, etc. So, by proportioning of footing, the differential settlements are minimized so that they equalize the average bearing pressure under all the column. So, each load consists of, in each column, it consists of dead load, live load. So, full live load does not exist in all time in all the column. So, dead load plus full live load is not a realistic criterion for producing an equal settlement. So for actual load, we are expected on the building as a dead load plus 15% of live load. So the procedure for proportioning of footing. So dead load including, so what are the dead load means self weight of the column. So that dead load should not be that should be noted for each column of your footing. Next, live load for each column is to be calculated as per IS code. Next, the ratio of dead load to, that is live load to dead load, is calculated for each column footing and maximum value of ratio is noted. Then the allowable bearing pressure is calculated by Terasaki equation. For the footing with largest live load to dead load ratio, the area of footing required is calculated by total load by allowable bearing pressure. Then the service load of the column is calculated by adding appropriate fraction of dead load, that is live load to dead load. So next is the design bearing capacity is obtained by dividing the service load of maximum live load to dead load ratio by the area of footing. This pressure should be less than the pressure computed in step 4. Next, the area of the footing of each column is obtained by dividing the corresponding service load by the allowable bearing pressure. So, the design procedure for proportioning of rectangular footing. First, we consider as a dead load plus reduced live load. Reduced live load means 15% of live load acting on the column. So, step 1 to find the column load. So, capital Q equal to Q1 plus Q2. Q1 is a load in an exterior column and Q2 is a load in an interior column. And step 2 is find the area of the footing. So area of the footing is calculated as capital Q, that is total load, divided by QNA. QNA is allowable bearing pressure. And next step 3, to locate the line of action of column load, measure from the center of exterior column, that is x1 bar equal to Q2 x2 divided by Q1 plus Q2. Here x2 is a center to center distance between the column. And the next step is define the total length of the footing. So length of the footing is calculated as L equal to 2 into x bar plus E1. Here E1 is a projection of your footing. Next step 5 is to find the width of the footing, that is capital B equal to area by L. Next step is to find the actual area provided, that is A0. And in 7th step is find the actual pressure. Up to 7th step we find the dimension, that is area and B. That is area, that is B into B and the L. After the step 7 we consider there is an act of dead load plus full live load. So therefore Q max is calculated. Q max equal to capital Q divided by A0 into 1 plus 6E divided by L. And Q minimum is capital Q divided by A0 into 1 minus 6E divided by L. These Q max and Q minimum should be less than the allowable bearing pressure. If it is less than means, then it is safe. Otherwise, we want to redesign the dimension of the footing. So let's see one problem. So proportioning a rectangular combined footing for a uniform pressure under a dead load plus reduced live load with have the following allowable bearing pressure. Therefore, dead load plus reduced live load is given as 180 kilonewton per meter square. If the dead load plus full live load means 270 kilonewton per meter square. So first step is to calculate a column load. Sorry, here the column load is given in a question, that is load, dead load, live load, column A, column B. Column A is 500 and live load is 400. In column B, dead load is 660 and live load is 840. And center to center distance of the column is given as 5 meter and projection of footing is 0.5 meter. So first step is to determine the column load. That is column load. Here we are considering a two cases. So first case is dead load plus reduced live load. Reduced is nothing but 50%. So converted as a point is 0.5. So in column A, the dead load is 500 plus reduced is 50%. So 50% is 0.5 into live load is 400. So which is equal to 700 kilonewton. For column B, the dead load is 660 plus reduced is 0.5, live load is 840, which is equal to 1080 kilonewton. So in case dead load plus reduced live load, the total column load is 1780 kilonewton. Next case is dead load plus full live load. So in column A, dead load is 500 plus live load is 400, so which is equal to 900 kilonewton. So in column B, the dead load is 660 and live load is 840. So totally 1500 kilonewton. Therefore, total load in dead load plus live load condition is 2400 kilonewton. So first let us assume a case 1, that is dead load plus 50% of live load acting on it. So to find the column load, capital Q equal to Q1 plus Q2. So we are assuming the cases dead load plus reduced live load. So we are taking the load on that condition only, that is 700 plus 1080, which is equal to 1780 kilonewton. Second step is to find the area of the footing, that is capital A equal to capital Q divided by QNA. So capital Q is calculated 1780 divided by QNA is allowable bearing pressure for dead load plus reduced live load condition. That is 180, which is equal to 9.88 meters square. Next step is to locate the line of action of a column load. So that is x1 bar equal to q2 x2 divided by q1 plus q2. q1 is load at the first column and q2 is load in the second column. By substituting the values, we get x1 bar equal to 3.03 meter. Next step to find the total length of the footing. So total length of the footing is calculated as L equal to 2 into x1 bar plus E1. So therefore L equal to 2 into x1 bar is value is 3.03 plus E value is 0.5. Therefore L equal to 7.06 meter. Next steps to find the width of the footing. So we already know that A equal to B into L. Therefore, B equal to A by L. By substituting the value, we get this width as 1.4 meter. Next, find the actual area provided, that is A naught equal to B into L, that is 1.4 into 7.06, which is equal to 9.88 meters square. Next steps is to find the actual pressure, that is Q max equal to capital Q divided by A naught into 1 plus 6E divided by L. And Q minimum is capital Q divided by A naught into 1 minus 6E divided by L. Here we are considering a full dead load and full live load acting on that dimension. So here x2 bar equal to q2 x2 divided by q1 plus q2. Here q2 is a column load on second column and x2 is a center to center distance divided by total load. By substituting the value, we get the value x2 bar equal to 3.125 meter. Therefore, E equal to x1 bar minus x2 bar, which is equal to 3.03 minus 3.125, which is approximately equal to 0.1 meter. Next, we are going to find a value of Q max. So, Q max is capital Q divided by A naught into 1 plus 6 E value is 0.1 divided by L. So L value is 7.06. By substituting the value, we get the value as 263.04, which is less than allowable bearing pressure. Next one is Q minimum. Q minimum is capital Q divided by A naught into 1 minus 6 E divided by L. Here the value, by substituting the value, we get the value as 222.7, so which is less than 270 kilonewton per meter square. So here Q max and Q minimum is less than the allowable bearing pressure. Therefore the dimension of the footing is okay. Therefore hence okay. So provide a rectangular footing of size 7.06 into 1.4 meter.